Right. Hi. My name is Yandu. I've been at Shopify for the last 2 years on the data engineering team. And I'm just going to go through what we've been doing, how we moved from our old data infrastructure, why we had to move, and why we chose Spark, and sort of our growing pains along the way. So Shopify. Shopify is a fully hosted e-commerce, or commerce solution, I should say, that handles everything that a merchant needs to run their business, both online and offline. So inventory management, ability to add products, easily customize their stores, and with the ability to handle large, we call them flash sales, where somebody will put up a sale that only lasts for 15, 20 minutes, and we see spikes in traffic that would normally knock over most other e-commerce solutions, but we've done a lot of work to handle that. So from that, lots of data comes in that our business executives and people within Shopify would like to use to make the product better. So when I first started, we had a Ruby ETL framework that was very light on the T part. We didn't really do any transformations. It was pretty much a direct copy of our operational data sets into Vertica. And Vertica was a 6-node data warehouse cluster. And the reporting engine was a homegrown thing we call Tiller, which is a CoffeeScript web app. So some of the reasons why we had to move, one of them was just sheer data volume. Shopify is has been growing at 2x year over year. So with that, we just couldn't, we didn't want to keep putting everything into Vertica. It would just, the licensing got a bit too expensive. The other thing was the data and query complexity. So the way it worked was similar to what was talked about in the keynote. We had data analysts that each reported into a specific business unit and did ad hoc queries for their particular business unit as they needed it. It slowed down the iteration cycle. There was single reports were just pages and pages of data, or of SQL in complexity, and these were key metrics that we needed. So it led to a lot of tribal knowledge of just, well, you have to filter this out, you can't use these fields, you have to actually aggregate stuff this way. And it became a real bottleneck as the company grew, because the information would be siloed with one person. So we weren't able to provide the level of service that we wanted. And anytime we needed to make a change, it involved like weeks of work by analysts just to bring everything back up and reconcile and all that. The other thing, performance issues. So having Vertica as essentially our dumping ground for all of our transactional database information, and then also trying to do complex queries on top of that without any optimized tables or modeling, led to Vertica either being unresponsive or just not being able to do the queries or handle the load at peak times. So for certain queries that we knew were complex and always had people asking them, we'd materialize them and store that in a table. But generally, everything was modeled and done at query time. So we decided we had to move. We wanted to move to HDFS so that we could start handling all of the data volume that has been coming in. We tried Pig and Uzi, we tried Pig and Luigi, and both of those Pig was just not very nice to work with. It was slow, it was very cumbersome. The UDFs weren't very intuitive. Finally, we looked at Platfora, and they say, without coding or ETL, data warehousing, BI tools, or breaking a sweat. So this is how you can unlock the data that you've got, which we thought was just an amazing idea. Like, with this now, our problem solved. We thought that we could have self-serve data within a couple months. But we found out there's no free lunch. Platfora just didn't deal with cleaning and joining and modeling our data the way we needed it in order to be able to present it to our business users. So enter Spark. It's fast. It was in memory, so it was MapReduce, but implemented with hindsight, not a lot of the gotchas that MapReduce has. The development model with the Spark shell and PySpark shell was really nice. Fast iteration, being able to just pop something open, immediately start looking at your data was really nice and a fun way to just explore and get used to it. And the real selling point was Python for us. We're a Ruby on Rails shop, so dynamic interpreted languages are what we know. So the idea of trying to build something in scalding or cascading just didn't really fly because we didn't have the expertise in-house to deal with Java or with Scala. We just didn't know how to build out a big scale project with that. With Python, we already had the expertise in-house. So it was the clear winner. So we started reading the good book, as we call it, which is the data warehousing toolkit written by Kimball. So star schemas, making sure you've got conform dimensions, and going about, and very clean data so that it's easy for users to use, but it's also very hard to get wrong answers out of. So now I'm going to just talk about one of the initial sort of wins that we got for this data modeling effort that we did. So GMV is one of our key metrics. It's gross merchandise volume, and that's how much money moves through Shopify, how much the merchants sell through Shopify. So for this, it's always been a key metric, but before it was, again, like pages and pages of SQL. And so right now the numbers are, we've got 165,000 plus active merchants, and we've processed $8 billion worth of merchandise. So when we went to the finance team to initially do this, we got our analysts and developers together. They did interviews with them to make sure that what we were modeling was actually what they needed. One of the big takeaways was that although the numbers were correct that we were producing with the old model, the grain wasn't right for them. They could do a lot more if we dropped down in granularity to away from the orders and into order transactions. So that's everything that happens within an order. So if there's partial refunds, or if there's a return, or they use different payment methods, they maybe used a gift card for a bit, all this stuff gets tracked at this granular level. So that's what we had to work towards. Then once we got that implemented, the big part was now building up trust in the new system. So this was completely new. The old numbers were correct. Why did we need this? So the analysts spent a lot of time showing that not only were the numbers correct in aggregate, but also you could go down to the row, an old row from the old system mapped to a row in the new system. And so we built up trust, and now this is something that, as a public company, we use and we report against. So it has to be rock solid. It wasn't all smooth. There were growing pains. This graph here shows what we were trying to do a join. So at the end of the fact table build, we try and do a resolve. So we take the natural keys and we map them to surrogate keys on the dimensions. That is our entire cluster running out of memory because we're trying to do a join on skewed data. What we found was that joins, groupings, certain things would try and materialize large volumes of data, and because we were on PySpark that grew unbounded, one job could actually take out our entire cluster. We spent a lot of time getting to know this and also Python's other performance quirks. What we developed was a library we call Starscream. which has certain things like specialized joins. So we tried to do broadcast joins, but also if only parts of our data are skewed, so there might be some shops that do a lot of transactions, then we'll move those out, do a broadcast just for them, because doing the resolve step is a special use case of that, where many millions of facts will just go down to one dimension. So we can use that knowledge to be able to minimize the number of values that we broadcast. And then the other stuff, so these are all resolvers. So we've got range resolvers as well, where facts happen at a particular time, and we want to know as to what stage in the funnel our customer was in. So were they a prospect, a lead, et cetera. So we had to develop different join strategies to be able to handle this. And now we're also using Cassandra to help with the resolvers. So a lot of what we've done is try to use Spark for what it's really good for, which is pipelining, mapping, filtering, that sort of stuff. And then for the random lookup stuff or joins, we try to either convert it so that the RDDs are ordered in a particular way so that we can map over it and use Cassandra for lookups and joins and stuff like that. We also, because we use Python, we lost some of the type safety that you get from Scala. So we started using, we built these contracts, which are runtime checks, runtime sanity checks, to make sure that the data that comes out is actually in the form that we expect. And we're going to extend this to make sure that the different workflows can plug into each other based on the contracts of the input and output. And we now are sort of moving also to incrementalizing our fact builds. Rather than rebuilding the entire data set each day, we want to just rebuild the parts that have changed, similar to sort of how SAMSA does it with rehydrating all the important information, just working on the deltas and then pushing that back out. So here is our current stack. We've got Kafka and our online transactional processing database, which is MySQL, dumping data into HDFS. Spark will pick that up, model it through using Starscream. We push some of the data into Cassandra that we need for the resolve steps and the joins. And Cassandra, we also pull from it to do those resolve steps. Once that's all done, that's considered our backroom. So that's not user-facing. That's where we do all of our work. And then the front room is where the business users will actually interact with our data. So that is a Redshift database holding all the model data, and Tableau on top doing the reporting. And it's been a huge success for us. The biggest users now of our data are people in the finance team that before didn't use it, or they'd go straight through their analysts. Now they're actually self-sufficient, and they can answer their own questions with not a whole lot of effort. So I think, yeah, that's it. So thank you.
I can take one or two questions.
Real quick, I was going to ask you about concurrency and multi-tenancy in the cluster, but I guess you have your end users actually running off of Redshift, not running queries against Spark, so that might not be relevant.
Yeah, so
Okay.
we do have, we're looking at operational data stores. So for developers that just want to do some very quick queries just to see usage for a particular shop or something like that, we do use Impala. We're looking at maybe switching over to Presto to do it. But we've got, I should say, we run Spark on Yarn so that to do the resource management. Before it was standalone, and that we ran into a lot of performance issues with that. Just
Any reason for embracing Impala when you could just be running Spark queries? Any reason why you didn't think that would be sufficient?
Well, right now the reason is our data is in JSON, and it just does not play well with, or there's no reason that we haven't moved to Spark SQL. We just haven't really had time to prototype it. Impala was there. We're on Cloudera, so we just started using it. And the Parquet format is quite nice. So. Anything else?
Okay, let's thank our speaker. And
Thank you.